Hello dear students, today we will start with a new chapter which is electrochemistry. This chapter may sound a little complicated, but once you understand it, it will become easy. So what is electrochemistry? From the name itself you can know that it has something to do with electrons and chemistry which involves something related to electrons. So, we can summarize in this manner that electrochemistry, it will basically be a branch of chemistry which will deal with chemical changes produced by electricity and the production of electricity by chemical changes. That means it includes any chemical changes which will be produced by electricity. Now in this chapter we will basically be studying about electrochemical cells. So let us see electrochemical changes. What is electrochemical changes? This means that chemical changes which involves flow of current. What is current? Current is the flow of electrons. So it basically involves chemical changes which involves flow of electrons. Any changes which results due to the flow of electron is known as electrochemical changes. Now, electrochemical changes is further divided into two categories, which are electrochemical cells, also known as galvanic cell, or electrolytic cell. Now, what is electrochemical cell? Electrochemical cell basically involves conversion of chemical energy to electrical energy. And in this case, remember one thing, that any reaction which we will study, it will be a redox reaction. What is redox reaction? It will involve both oxidation as well as reduction reaction. Combination of both oxidation and reduction reaction is known as redox reaction. So we will be studying only about redox reaction in any case. So in case of electrochemical cell or galvanic cell, the redox reaction which will occur will be spontaneous. It will involve a spontaneous redox reaction. And also the Gibbs free energy change will be negative in case of electrochemical cell. Now let us see electrolytical cell. In electrochemical cell, it involves the conversion of chemical energy to electrical energy. But in case of electrolytic cell, it will basically involve the conversion of electrical energy to chemical energy, just the opposite. In this case, the redox reaction which will occur, it will be a non-spontaneous reaction. So as a result, the Gibbs free energy change will be positive. So from here you can see that electrochemical cell and electrolytical cell are just the opposite of each other. Let us see one basic difference between electrochemical cell and electrolytic cell. This is electrochemical cell. In electrochemical cell, basically the cathode and anode are placed in two separate containers. The cathode is made up of copper and the anode is made up of zinc. And the cathode is also placed in a copper solution, basically copper sulfate, and zinc is also placed in zinc solution, zinc sulfate, and there is a salt bridge in order to maintain the electrical neutrality between these two solutions. Here, the cathode has a positive charge and anode has a negative charge. And the difference is that they are placed in two separate containers. But when it comes to electrolytic cell, they are placed in a single container. The cathode and anode, they are not placed in two separate containers. They are placed in a single container. And also, in case of electrolytic cell, the cathode has a negative charge, anode has a positive charge. In case of electrochemical cell, we saw that cathode had a positive charge and anode has a negative charge. But when we are talking about electrolytic cell, they will have opposite charges. That means cathode will have a negative charge and anode will have a positive charge. So you can basically conclude that electrochemical cell and electrolytic cell are completely opposite of each other. Let us first see the setup of electrochemical cell or galvanic cell. There is a Daniell cell in galvanic cell. Now what is Daniell cell? Daniell cell is a primary voltaic cell with copper anode and zinc amalgam cathode. What is a voltaic cell? It is basically a cell which uses chemical reaction to produce electricity. So it is basically a Daniell cell. Now let us see the apparatus or the setup. The right hand side is known as the cathode and the left hand side is known as the anode. Now the right hand side has a copper electrode, or we can say copper rod, and in the beaker there is copper solution, whereas in the left hand side this anode is made up of zinc. That means it is a zinc rod and the solution taken is zinc solution. You have to keep in mind that cathode has a positive charge and anode has a negative charge. And there is a salt bridge. Now what is the function of this salt bridge? This salt bridge is attached in between the cathodic solution and the anodic solution in order to complete the entire circuit and also to maintain electrical neutrality between these two solutions. Now don't get confused with the definition of Daniell cell, which says it is a primary voltaic cell with copper anode and zinc amalgam cathode. It is just a general definition. Cathode is taken as copper and anode is taken as zinc. So don't get confused, it was just a general definition. Now let us see what happens in the anode and the cathode. In the anode, the zinc of the rod gets converted to Zn2+ by releasing 2 electrons. We will not go into details, but we will just see everything in brief. So what happens in this anode is that zinc gets converted to Zn2+ with the release of electron. This electron travels to the cathode. We know that electricity is passing through it, and what is electricity? It is a flow of electron. So zinc gets converted to Zn2+ with the release of electron, and electron travels to the cathode. Now at the cathode, Cu2+ accepts the electron or takes the electron and gets converted to Cu, that means copper metal. Remember that you will get the pure metal only at the cathode. So here zinc releases the 2 electrons, copper 2+ accepts the electron and gets converted to Cu, copper metal. One thing which you have to remember is that at anode oxidation takes place and at the cathode reduction takes place. That means loss of electron is known as oxidation, which takes place at anode, and gain of electron is known as reduction, which takes place at the cathode. Now let us try to understand in a better way. Galvanic cell or electrochemical cell has a Daniell cell, which I have already explained. In the right hand side, always reduction will take place, and the right hand side electrode consists of copper and the solution is made up of copper. That means the solution which we use in that very beaker is copper sulfate solution. And in the left hand side, always oxidation will take place. It will have zinc rod and the solution used will be zinc solution, that means zinc sulfate solution. And the right hand side, where reduction takes place is known as cathode, having a positive charge, and in the left hand side where oxidation takes place is known as anode, which has a negative charge. Now let us see what are the reaction taking place. As I already explained, at anode, zinc gets converted to Zn2 plus with the release of electron. Now this is the oxidation half cell reaction. Why oxidation half cell reaction? We have already discussed that in the left hand side and at the anode always oxidation takes place because there is loss of electron. Electron is lost and loss of electron is known as oxidation. So at anode, Zn gets converted to Zn2 plus with the loss of electron. So this is known as oxidation half cell reaction. At cathode, what happens is the electron given out at the anode travels to the cathode and Cu2 plus accepts the electron and gets converted to copper. Here gain of electron is taking place, and gain of electron we know that it is reduction. So this reaction taking place at the cathode is known as reduction half cell reaction. These are the half reaction. Now you will understand why we are calling it a half cell reaction when we see the overall reaction. In the overall apparatus or the setup made in the galvanic cell having anode, cathode and two beakers with a salt bridge, in the entire setup there is a one reaction taking place, which is Cu2 plus Zn, which is getting converted to Cu and Zn2 plus. This is the overall reaction. Now how Cu2 plus is getting converted to Cu? There will always be one more reaction which is taking place. The conversion of Cu2 plus to Cu, this is known as a half reaction. The full reaction will consist of both copper and zinc. Copper reacting and forming Cu is known as one half reaction, and Zn reacting and forming Zn2 plus, this is also one half reaction. When these two half reaction combines together, they will form a overall reaction, that is Cu2 plus Zns gets converted to Cu and Zn2 plus. I hope you are getting what I am explaining. Once again I will tell you, this is the overall reaction. When we write overall reaction, we cannot write every step how Cu2 plus is getting converted to Cu or how Zn2 plus is getting converted to Zn is getting converted to Zn2 plus. We cannot write every single step. Before we get one overall reaction, there will be many reactions forming. The first reaction, second reaction, third reaction, and at last we get the final reaction. Those reactions taking place first, second, that is known as your half reactions. The first reaction which takes place is Zn releases electron forming Zn2 plus. This is the first reaction. Then this electron travels to the cathode giving Cu copper metal. Now those two reactions which is occurring as the initial step, they combine to give a total reaction. That is why they are known as the half reactions, and when they combine together they are becoming a full reaction. So I'm sure by now it is getting a little clear how and why they are known as half reaction. Oxidation because oxidation is taking place, reduction because reduction is taking place. Half reaction because they are the half reaction of the overall reaction. They are just the initial steps. How Zn is getting converted to Zn2 plus, we are showing in this half reaction. How Cu2 plus is getting converted to Cu, we are showing in this reaction. When they combine together, they will give you overall reaction. Now let us see the overall reaction once again. Cu2 plus is in aqueous state, Zn is in solid state. The product from copper is also in solid state and Zn2 plus is in aqueous state. Now let us try to understand why the states are different. In the first reaction which is taking place at the anode, Zn is in solid state, which means that this Zn is coming from the electrode. This Zn on the electrode, it gives out 2 electrons and gets converted to Zn2 plus. Now this electron travels to the cathode, and you can see from the reaction that Cu2 plus is in aqueous state. That means this is coming from the solution. The solution which is placed in the beaker, that is the copper sulfate solution. This Cu2 plus is coming from the solution. The electrode given out at the anode travels to the cathode, and then the Cu2 plus of the solution accepts the 2 electron and then gets converted to copper solid, which gets deposited on the cathode. You will always find your pure metal on the cathode, I have already told you. So this copper from the solution, it accepts the 2 electron, then go and deposit on the cathode electrode. That is why it is in solid form. Here the solid zinc from the anode gives out 2 electron and also releases Zn2 plus in the solution. That is why it is in aqueous state. This is in aqueous state because the copper 2 plus from the solution accepts the 2 electron and gets converted to copper, which is in solid form, and it gets deposited on the cathode electrode. That is why their states are different. Now there is a trick in order to remember which electrode will be known as anode and which will have positive or negative charges. You have to remember this LOAN, lone. L for left, O for oxidation, A for anode, N for negative. That means on the left electrode oxidation is taking place and it is named as anode, which has a negative charge. So automatically we will get an idea about the right hand side electrode, which will be cathode, where reduction will be taking place and it will have a positive charge. That means if you just remember this for the anode, the opposite is for the cathode. That means it will be right, reduction, cathode, and then it will be positive. So if you just remember this, you can easily tell the properties and characteristic of cathode.